Dwayne, thank you for the introduction. Just in case some of you haven't seen me yet before, my name is Michael Grant. I'm the Director of Technical Consulting at Anaconda, and what that means is that I lead our team of data scientists and computational mathematicians and developers that help our customers implement solutions on top of Anaconda. If you have needs of that sort, I'd love to talk to you. I'm a computational mathematician by experience, and so this is in academic training, and this is going to be a different kind of talk for me because normally when I give a talk of on that academic subject, I'm picking something I'm an expert in, and I'm an internationally recognized expert in certain things, so that I can count on when I give a talk. If somebody in the audience disagrees with me, the problem is that they're wrong and I'm right. That's not going to be the case here. But the fact of the matter is that I've been doing mathematical modeling for a long time. In fact, I was accidentally pulled into that in a summer internship when I was 16 years old for General Motors, and that's a story for another time. That chicken there is not really with our model risk office. That's sort of a joke, but at the same time, there's kind of a lot that chicken might have in common, with the model risk officer. If you think about it, he's looking over my shoulder. He's probably telling me what I'm doing wrong in my ear. And let's face it, there's probably a fine line between appropriately risk-averse and being a chicken. Does that make sense? Okay, anyway, I'll let that go. But again, as I said, I think this is an interesting talk for me because I honestly believe that a lot of people will end up disagreeing with what I consider to be model management for the purpose of this talk. And I want to acknowledge that up front. What I'm presenting to you today is effectively an amalgam of case study. In other words, I'm sharing experiences that we have actually had with customers and their model management needs. But acknowledging that your needs are likely to differ from theirs. And I said an amalgam because I've also augmented it with some retrospective improvements. So things that I think we could do better, even in that particular case. And also now that we have Anaconda Enterprise on the scene, how we can use Anaconda Enterprise to further improve that model management workflow. And so really, I just want to make the point that there are going to be multiple paths to truth in model management. I'm going to be talking about one. I hope at least a chunk of it resonates with you today. The chicken has an opinion about that. So let me move on. This is another quote that I think I hope will help to motivate the talk. This is something I used in my doctoral dissertation. I suppose it is tempting if the only tool you have is a hammer to treat everything as if it were a nail. So, for example, if some of you out there are saying, well, of course, he's with Anaconda Inc., he's going to say use Anaconda for model management. I understand that sentiment. But here's a couple of arguments I would make. It is certainly true that if somebody built a monolithic product for model management, they would expect you to reshape your model management strategy to fit their product. That would be the one tool and nail argument. My argument is that Anaconda is Home Depot. All right, if you can't build your model management solution with Anaconda, just like if you can't build that backyard tool shed with what you find at Home Depot, you should build it differently. And so I have high confidence that while we may disagree on what exactly you need for model management, that the Anaconda ecosystem has what it takes to implement a good chunk of it. And so an executive summary, again, model management is not one size fits all. I do want to talk about my notion of the full model stack, make sure that we understand what a model is in the context of the management process. And my overall thesis is I want to leverage existing software-centric tools and practices to implement model management. In particular, I'm featuring heavily Conda and Anaconda Repository. Anaconda Enterprise itself plays a role, and even things like source control and CI systems. And the goal here is to describe a solution for distribution, deployment, and reproducibility goals. Okay? So let's talk about that. The reason why everybody thinks of a different thing when they think about model management is because everyone's models are different and everyone's idea of management is different. Let's pick apart model first. Is this what your model looks like? A couple of things about that. I would say not, because first of all, in order to have a model, you have to have, even if it is a simple, say, logistic regression, you've got to have the coefficients. Those coefficients came from somewhere. And point number one is that I am focused on the model that is already trained or already locked in place. It's an instance of a model that is presumably going to be approved for deployment to production. The training process is outside of the scope of this talk, okay? So that's point number one. But point number two is this is never the model by itself. It's necessarily going to involve additional code for data loading and cleanup, perhaps some nonlinear feature engineering and other sorts of model preparation steps, and then finally the actual prediction. And then, of course, there's even code after that to deliver that prediction to the appropriate surrounding application. And so a model necessarily involves a reasonable amount of code, a non-trivial amount of code, and that is part of the model in my view. But perhaps your model looks more like this. What is this? This is an actual data flow graph for a model that we have helped a customer implement. By the way, we helped them port it from SAS. So that's a little, trigger for any of you. Come talk to me about that. Each one of the nodes represents an individual calculation in the model, and then the lines, of course, represent the dependencies between those calculations. This obviously was a little more code than that previous example. Again, this is an actual model that we helped our customer implement. And they're very happy with the results, and they're now making decisions in Python instead of SAS, and I'm really happy about that in particular. So again, what is your model? It differs from person to person, from domain to domain. Now, what is model management? For this, I would say that it may very well involve one or more of the following: ideas or concepts, and perhaps others that I'm failing to think of and record here. For example, I think of an approval process, particularly for domains where there is a regulatory requirement or a governance need or a risk-based governance need. There is some sort of approval process, perhaps by independent model risk officers, where there's a subjective appraisal. Is the model attempting to do the right thing? And then but I separate that from validation, which is a much more objective, test-oriented approach to verify that the model actually accomplishes what you say it is trying to accomplish. Okay, I think both of those things need to be evaluated in any approval process. Deployment: how do I take a model that I have agreed is the right one for the job and push it to a production application? What does that look like? Or maybe closely related to that is distribution. So how do I deliver that model to, say, a family of business analysts that need to use that to build actionable intelligence with? And perhaps, and this one is a big one for me, and I know it is for some of the people I've even talked to already at AnacondaCon, reproducibility. I want to be able to take, let's say, six months from now, I get a call, Michael, the model that you built 6 months ago, actually, now that we've looked at the data, historical data, deviated more than we expected from actual performance. We need to understand why. I need you to retrieve that model and do some additional runs so that we can understand where it fell short. I need to be able to do that and reliably produce the same results that it would have produced 6 months ago when I first deployed it, okay? That need to do reproducibility, there are a lot of reasons why we need that. And to be perfectly honest with you, I would argue that if we can properly characterize and solve that problem, many of the other pieces end up falling into place relatively simply. So what I want to focus on now is talk about what it looks like to have a reproducible model in the Anaconda ecosystem. And so my idea is this: I want to be able to, given a blank slate, as a modeler, I'd like to be able to retrieve a model from a specific point in history. Given a particular time that I need to retrieve from, or a particular model version, I want to be able to retrieve that model, install it into a compatible computational environment. I haven't defined what that means yet, but I'm going to. I want to be able to trust or verify that the model is operating correctly, that it still does what it did when it was first built and deployed. And then I want to be able to, of course, use that model to perform new analyses. Okay, so that's kind of the concept that I have in mind here. And with that in mind, let's talk about that. What do I need to do? What does the instance of a model look like in that context? And I've chosen to break it up conceptually into a number of different pieces. First, is the model instance. This is what's likely to change from model iteration to model iteration. This is what's likely to have to go through the risk-based or governance process of approval and validation. So it's the top-level code, it's the parameters, it's the logistic regression coefficients, it's the neural network structures, it's all of these things. Then below that, one level below that, is a framework. This is probably code that is developed custom in-house. It encapsulates kind of your business uses for that model, but it's domain-specific, it's likely business-specific. And then below that would be the more generic libraries, pandas, scikit-learn, TensorFlow. And perhaps, depending on how shall I put it, paranoid you are about the reproducibility question, that may include a specification of the operating system. Okay, I have opinions about that, but anyway, the point is that anything that's more generic and not model specific would go in that infrastructure line. And then finally, validation data. So the idea is if I'm going to reproduce the model 6 months from now, I need some way to verify that it's performing the correct computations. And so this would probably include some reference inputs, say a certain demographic subset of my model inputs from that time period and the outputs that the model generated on that reference input sample. That's actually an important part, I would contend, of the model stack, particularly when where reproducibility is concerned. I need to be able to verify after the fact that the model is still performing as I expect it to. Now, what I've observed when we worked with customer is that each of these, and one of the reasons I wanted to break this up into pieces, is that each of these pieces often gets versioned differently. Now, it's no surprise that the model instance may be the one that changes more often. Okay, I'm going to be updating those coefficients. I'm going to be modifying my smoothing parameters. I'm going to be updating my global assumptions, maybe my interest rates or some other, variable parameter. That's going to be changing the most often, and it's going to have a version. In this particular case, I've chosen a regular monthly cadence for that. The model framework, in theory, especially if you have a somewhat mature model, doesn't need to change that often. Okay, but periodically you decide that in order to accurately improve the model, I have to implement a new approach to a particular section of the model, and that may involve improving the model framework, and that means releasing a new version of that underneath the model instance. And likewise, every time I'm at least considering updating the model framework, I should also consider updating the model infrastructure. Want to see if the latest version of pandas, can give me some extra tools, or maybe NumPy's been improved, for instance, or Dask. And I will tell you that this is something that you have to take seriously, because while at the same time you might get improvements, there's a non-trivial chance, and I have seen this happen in practice, that it will break your code. Okay, so model infrastructure is not something you just want to allow to stay on the bleeding edge for. You want to be deliberate about evaluating updates to the packages you depend on the most, and make a reasoned and careful and tested decision to include them in your model stack. And then finally, your validation data. This one actually is something that perhaps surprised me the most in my experience with a customer. The basic idea here was that the input sample for the model was fixed and periodically updated, but at a much lower cadence than the rest of the modeling environment. And so they had something that called an official sample, and that would be that changed periodically, but relatively slowly. Now, of course, every time you update the model instance, that means you recompute the values on that official sample, and then the results of that, the reference output, is in effect packaged with the model instance itself. But the model input data does not necessarily have to track with the same version cadence as everything else in your model, version dance here. Now, this is somewhat idealized, I have to admit. Let me give you a little bit of a peek at what we actually had to deal with this customer. And the reason, it turned out that we were updating the underlying versions of the model very frequently. And the reason for that is because, we were still maturing the model framework and how we were doing that. This posed a particularly interesting challenge to the approvers of these models, because we were making changes to the underlying model framework that we needed to certify did not affect the numerical results. And so we had to negotiate with them to obtain a set of tests that we could run to verify that these changes that we were making to the model framework, which improved the functionality of the model in the context of the business applications, was not actually impacting the numerical results coming out of the model. In fact, I actually never met the model developers. It was really interesting. I mean, there was genuine firewall there. So we had to verify that we were getting the right numerical results, but we had some freedom to improve the model framework for functionality purposes. So this is obviously a different version cadence, but the point either way is that each of these pieces of the model stack are going to be separately versioned and need to be separately considered. And so then that leads to me to some questions. How do I manage those versioning requirements at each level? And furthermore, how precisely must I define the computational environment? A particular question, do I really have to spin up a Docker container? I mean, can I get sufficient reproducibility without that? And then what do I do with the validation data? It's my contention that that is a critical part of the model management, the model stack, and it needs to be managed alongside the code and the model parameters and so forth. I need a way to version that. I need a way to store it, and I need a way to distribute it. So, again, as I indicated in my executive summary, I claim that we can tackle these problems using aspects of the Anaconda ecosystem. And the first is the Conda package and environment management system. We can use Conda to ensure that the correct combination of packages are installed. That when we install a particular model instance, we automatically install the correct versions of the model framework, the model infrastructure, and we retrieve the correct reference data. Okay? Conda's environment management capabilities allow us to create separate, isolated binary environments on the same machine. Each can have a separate and distinct Python and NumPy stack, and therefore, a simple way to look at this would be that each Conda environment can contain a separate model. And that provides a certain level of isolation, which could very well be sufficient for your purposes, especially if you have a robust testing framework and numerical validation framework for these models. That's the position that we prevailed on the customer in this particular case. A more advanced approach would actually be to allow multiple model instances to live inside the same environment as long as they all depend on the same versions of the model infrastructure. I will say this is certainly going to be more convenient for an analyst who needs to do historical analysis or A/B testing or anything of that sort, although it's not strictly necessary. And you can even be really, with a little bit of custom work, you can do things like dynamically load in the model in the same process and do rapid A/B comparisons. But as I will show, in fact, it's not strictly necessary to do effective A/B analysis to have the models in the same environment. Okay? Anaconda Repository, step 2 in this solution for reproducibility. This is where you would put these packages, these assets in your model stack. The model instance has its own Conda packages, the model framework, the model data, they all have their own packages. You version them and store them in the repository. And some important features of this is the support for multiple channels, or even within a channel, multiple labels. So the idea would be that to most users, you would expose only the production model sets. So the models that have gone through the full approval process. Okay? But it is entirely reasonable to have a separate channel or sub-channel to store and version and retrieve development models, in the middle of the approval process. And I'm going to talk a little bit later about what that looks like to actually use the Conda package management system to help people analyze and study and engage in the approval process for models in development. And I might also add that customers sometimes have the desire to support off-label, unofficial experimental models. They have not been approved for production, but you give the modelers the freedom to build packages that branch off of the base, maybe just for purely speculative purposes, that branch off the production model version history and implement customizations. And we want to give them a way to to upload them and archive them and retrieve them later for further analysis if they choose. Okay, so the repository is flexible enough to support a variety of use cases for retrieving models in both current and historical. And the access control for the repository is quite flexible. I can have a channel that is limited, whose access is limited only to certain users. And if I'm engaged in any sort of automatic deployment of models to production, I can create tokens that will allow that application or that cron job or that GitHub trigger or whatnot to automatically access, be given privileged access to that production channel for model upload. Okay. Now, finally, Anaconda Enterprise. I joked, did I really have to instantiate a Docker container just to get the level of isolation I need? Well, the good news is that in many instances, it's actually not, it's off-label to even run a model on your local laptop anyway, right? I mean, there may be security concerns about the data. You don't want it to live on individual laptops. That's fine. One of the great things about Anaconda Enterprise is that we can bring the full Anaconda distribution stack and any packages that you build yourself and host on your internal Anaconda repository can be used on Anaconda Enterprise. And if you do that, well, you get that extra level of isolation because every single project is given its own Docker container, and this is all managed by Kubernetes. So you get that additional level of isolation and resource control by using Anaconda Enterprise. So for those that do believe that, yes, I need isolation all the way down to the OS level, Anaconda Enterprise will actually give that to you. All right? The Python environments inside each project are managed by Conda, so all of those advantages that I just described with Conda for version management are available within Python projects. And depending on how I configure it, if I have a project who's designed to simply present to me the latest production model, every time I refresh my model project, I'm going to get the latest model. And every time I redo a deployment, I can by default get the latest model. Okay, so it's naturally compatible and powered by the versioning and dependency management capabilities of Conda. So Anaconda Enterprise, and these are new capabilities that in the case study aspect of this talk, I can't say that we have enjoyed yet. This is something that I wish I had when we were developing the solution for our customer. Okay, so this is a funny thing. I mean, it is true. When people think about Conda packages, they assume that this is for packages, this is for code, this is for applications and so forth. What about the data? And the fact of the matter is that that's a little bit of a myth. Conda is not just for code. It never has been, although, I mean, it's commonly considered that way. It's nothing more. A Conda package is a binary archive plus metadata. And so there's no reason that we can't store validation data, reference data, inside the Conda package itself, okay? And you can use a variety of formats because, again, it's a binary archive. So just store the data in that Conda package and upload it to Anaconda repo. You get the benefits of versioning and distribution right there from the repository, excuse me. On the other hand, that's not always how the data presents itself. In particular, if you have a reliable historical database, you may not need to store all the data in the package itself. Instead, store an index vector or a SQL query with appropriate, date buckets or date bounds, and you store that description of your data inside the Conda package itself instead. Okay, perhaps the code or the data is stored in an S3 bucket, and every time the model data is updated, you create a new subdirectory within that bucket, and inside this Conda package would be effectively the URL of that S3 directory that you use for your data. Okay, so there's a variety of ways to slice this, but the point is that Conda is certainly well suited for managing a versioned data package. And in fact, it's so well suited for this that we have a new project that, even though it's brand new, even though it's pre-release, it's something that I'm genuinely excited about, and I want to share with you. It's called Intake. It's a Python API for bulk data, and it has a bunch of lightweight plugins for data loaders in various file formats in CSV, Parquet, Postgres, and so forth. And it will load directly into Pandas data frames or NumPy arrays, including Daskified or distributed out-of-core versions of same. Okay, and it basically simplifies, from my perspective and for the perspective of this talk, it simplifies the process of building these versionable data packages that we can implement, that we can integrate into this model management process. Okay, so again, I may not want to store the actual data itself in the packages, so instead I store a description or the intake requirements for that package, for that data in the package itself instead. This is an open source package. It always will be. It's BSD licensed, quite liberally licensed, And I invite you to check it out. It's pre-release. I feel warn you about that. But again, you know what's great about working at Anaconda is we identify these needs as we work with our customers, and sometimes they get turned into projects like this, and it multiplies their value. So I've already been using this to good effect, and I invite you to consider it. Okay, so let's take a look at an example. This is a nosy chicken. But he's making a good point. I've done a lot of talking. I wanted to give you a live demo. It may be, a little bit unreasonable in this particular context, but I did want to show you what it looks like to use Conda to manage the models in this way and see what that version cadence looks like. So I put this slide up before, I'm doing it again as a reminder that what I've done is I've created a channel on Anaconda Cloud, which is our public package repository, obviously not something that you're going to be using for your high security proprietary models, but you would be using an on-premises version of this same software. I've created a channel for a model that I called MCG model because I'm not creative. And as you can see, I have model instance, model data, and model framework packages. What I don't have is model infrastructure packages. And the reason for that is that the infrastructure specification is actually contained inside the framework packages as a list of dependencies. So in other words, the model framework package itself tells you what versions of pandas and NumPy and so forth that it depends on. So if I take a look, this is an example of a version instance package, and what I've done is I've specified the particular version of the model data that this model instance depends on and the particular version of the model framework that this depends on. And they're pinned to that. So that gives you confidence that the right version of both of those packages are going to be installed whenever you install your model instance, okay? And then similarly for model framework, as I indicated, the dependencies, the versions of Numba and NumPy and Pandas and Python that I'm using for this particular model framework are included in the dependency list. So this pins down to whatever level of specificity you are comfortable with. For example, I could pin Numba and NumPy all the way down to the build if I chose. So it really depends on your level of risk tolerance here. And I see no reason not to pin quite aggressively in a situation like this. And so then this helps you establish the precise computational environment that your packages on your models are going to run on, okay? And so let's say for the sake of argument, I'm doing this on my Mac. I'm creating a Conda environment with an instance of the model. And so this is back in October. So the latest model that I've stored on the repository is the October 2017 model, and I'm creating an environment called mtest, and I'm installing model instance in it. And this is a truncation of the actual output of Conda. I actually ran this, and I copied the output and pasted it and edited it for brevity. And so what you can see here is that I'm installing intake. As I mentioned, I'm using that for data ingest, and I'm installing the appropriate versions of model data, model framework, and model instance, which is what I asked for. I didn't ask for all of those, by the way. Conda knew which ones to provide. And, of course, it selected the latest versions of the relevant dependencies. And so once I've created this environment, I activate it, and now I can do analysis on that model. And I could install things like Jupyter Notebook in this environment as well, and it makes sure that the version of Jupyter Notebook that it installed is compatible with all of these dependencies as well. Okay? So installing those additional packages won't corrupt the specifications that you have put forth for the model itself. All right, so November rolls around. I get a note from the model office that there's a new version. All I need to do is Conda update. And in this particular case, if you remember the version cadence, the model framework stayed the same, and the model data stayed the same. So the only thing that happens is that the model instance is updated. But December rolls around, and it's a little more complex. In this case, the model framework was updated, and the infrastructure packages were updated as well. We decided to go to Python 3.6 finally. And fortunately, the developers did enough testing. They confirmed that the model runs great on the latest versions of Numba and Pandas and Python. And so the December 2017 model has updated versions of all these dependencies. And so Conda did the right thing by updating all of those packages. If you would also install Jupyter, it would have to reinstall. So it would install the Python 3.6 build of Jupyter as well. So all of that will be handled automatically for you by Conda. All right, January. January is interesting. The model framework stayed the same, but the data, the official sample, the reference data changed. And so that's all we've updated in January. All right, now we'll throw you a curveball. Now I want to go back in time. I got that note from the office. I need to go back to October and study that model again and figure out what's going on. I could, if I wanted to, create a separate environment for that purpose. In fact, that's probably the most obvious thing I should do and not mess with my current production environment. But I can if I want to. So in this case, I downgrade to the October 2017 model. And when I do so, that means it has to downgrade the model instance and the model framework and model data packages to their proper versions. And I have to downgrade back to Python 3.5 as well, because that was what was used in October 2017. Okay? So Conda makes sure that all of this versioning dance is choreographed properly. And it's pretty straightforward. Now, of course, when you're using Anaconda Enterprise, you don't see that. So it's important to remember this is all command line work. But now now I'm feeling really badass. Okay, I want to have every single one of the models since October installed on my machine, and I'd like to be able to play with them whenever play with them in whatever order I want on demand. And so to do that, what I can do is I can create separate Conda environments for each and every one of those packages. Each one of those model instances. In each environment, it will be included the proper versions of the model framework and infrastructure and the model data. Okay? And by installing IPyKernel in each of those, I can create a master environment that includes Jupyter and the NB Conda kernels package, which helps Jupyter Notebook see all of these Conda environments. And now I can switch between models on demand and run the same notebook on all of them, generate reports, and then pull those reports together and build whatever kind of plots and charts and comparisons that I want to make for all of these models at the same time. Okay? And because, again, each model gets its own environment, I have binary level isolation. I have very high confidence that these models are behaving as they did when they were first instantiated and first deployed to production. And if I don't believe that, I've downloaded the model data, and if the model framework is properly designed, I can run the tests on each of those models and verify that they still meet their numerical requirements. Okay? Now, let's say that I'm happy with my model. I'm ready to distribute that to an Anaconda Enterprise project. It actually turns out it's pretty easy to do. I fire up Anaconda Enterprise and I open up my model project and go to the project specifications. I need to add my model channel, like MCG model, to the list of channels. And all I need to do is add model instance to the package list. If I don't add a version specification, then every time I start up this session, I start up the model session, I'm going to get the latest production version of the model. Okay? When the model office says that they've released a new version, I shut down the session, I start it up again, I get a brand new version of the model. Or I can manually pull the latest version with a conda command. But if I just shut it down and get a new one, or if somebody else fires up a new model, they can be sure they're going to get the latest version of the model. Okay? And again, I can do that same multi-model trick if I want to in an Anaconda Enterprise project, because projects have multiple environment capability. So a single project can host multiple model environments for you. If I want to deploy to production, on the other hand, there's a lot of different ways we can do that. With Anaconda Enterprise, it supports deployable applications as web apps or as REST APIs. With REST APIs, they're really interesting, by the way. I don't know if you've had a chance to see this, but there is a publish method or a publish decorator included in the Anaconda Enterprise Conda package. You can import that. And then what you do is you create functions in a Jupyter Notebook, give them a publish decorator, and then when the project is deployed, you've built a web API, a REST API with those functions. And so it's a really neat and very simple way for you to build out a REST API using Jupyter Notebooks. There's no, as much as I would love for you to build your entire model management strategy on top of Anaconda Enterprise, this is entirely possible to accomplish with standalone production servers and non-Anaconda assets. So simple examples would be cron jobs or GitHub or GitLab triggers that automatically trigger some sort of update process when a new model is pushed to production. Okay? So this hopefully gives us a reasonable confidence that we are going to have, that we have the means, assuming we could build the packages now, that's a fair, important assumption, that we can distribute these and we can deploy them, and we can retrieve in a reproducible, verifiably reproducible way, historical versions of the model. We can rewind the clock as much as we need to. Okay, so let's talk about the building process. Raise your hand if you went to the Conda build tutorial on Sunday. Anybody, by any chance? Okay, so hopefully you understand what Conda build looks like. This is our system for building Conda packages. The recipes for these packages is a very simple YAML format. Integrates really well with automated build systems like Circle or Travis and AppVeyor and so forth. And what I like in the context of this talk is the way that Conda build facilitates the automated testing of your package. So it doesn't just instantiate the environment and run the test code. It builds the Conda package first, and then it creates a new environment and installs that package into that test environment and runs the test there. And so in other words, what you're testing is not just the code itself, but the deployment and distribution strategy for that package as well. So I think it's an extra layer of assurance. When Conda build completes its tasks, when the tests have passed, you know that installing that Conda package is going to give you the correct results. I think that's actually a higher level of testing, and it may be subtle, but I think it's pretty important in this context. It's a higher level of assurance that your model is going to behave as you expect. And of course, with an automated build environment, you can detect the passage of those tests and upload the packages to repository on test passage. And what I recommend, and a technique that we use with one client, is that we had we uploaded to the production channel for master builds, and for any pull requests or other development builds, we uploaded to a different channel, or more precisely, a different label, so that production users never accidentally saw those out-of-spec models, okay? But really, we mean more than just building. We are talking about the approval process, and this is where I'm actually having to leave the Anaconda reservation and appeal to you that the software development world already has the solution that we need for model management, especially if we accept that models are so much about code. And yes, data too. But if code is such an important part of that, why not leverage existing software development practices? And so this is actually more case study and less aspirational. This is actually what we have done for customers, is to leverage GitHub, a software development tool, and software release management tool, if you will, version control tool, if you will, for the actual model approval process. So let's say we have a model that we're happy with, but it's time to update it with the new data. We create I'm going to describe this. We create a new Git branch, and we open a pull request immediately for that. Okay, that's a little bit different. A lot of times you don't open a pull request until you are ready to have the model reviewed. But by opening the pull request immediately, we begin the conversation with our colleagues about what this model update is going to have. Okay, so it turns out that the PR discussion thread is really powerful, and you can include screenshots and plots and a variety of other discussion features in there. So it's worth utilizing that, and it's a record. It's a record of that conversation. So every time you commit a new change of your model to the pull request, it can trigger a CI task. It'll run the validation tests, and if those validation tests pass, the Conda package will be uploaded to the dev channel. So now it's available for anyone involved in the model approval process to pull into their projects and analyze and study to see if the intent of the model is reflected accurately in the implementation. Okay, so you go through your model approval process. I'm not going to prescribe what that is. That depends on you. But once that approval is done, you merge the PR to master, and that triggers a different kind of build. It still has to pass the test, of course, but you can reasonably count on that it will at that point, although, believe me, sometimes you can make mistakes there. Assuming it passes, it will be uploaded to the production channel, and then you can trigger any sort of production deployments that you need at that point. All right? Now, there's a couple of ways you could do this. Here's a simple single branch idea. So the idea is that as soon as November, this is an example of going from 2017-10 to 2017-11. As soon as I want to begin that model change process, I open the pull request and start making individual changes to the model, each of which can be subject to scrutiny, analysis, study. You might have a set of reporting requirements for every proposed change to the model. okay? In this case, I've got 3 different changes, and then there's a final approval. And so, for example, there might be some administrative commit at the end that registers that the model risk office has signed off on it. Maybe you bump the version number, you set the tag, or whatever you need to do to mark that this is the commit that is going to make it into production. And then that gets merged into the master branch, and that's a simple approach to development. But one thing that's interesting is, my observations, is that this isn't always the way it goes. In many cases, there are multiple people working on model development. There are multiple people proposing changes to the model. And so there's a sort of a parallel process for developing that. And I think it's worth understanding how you can integrate that style of model development in with a GitHub pull request approach. So the approach that I would recommend here is that you begin with that same initial branch, and so that, and then each of the individual model developers creates a pull request against that branch, not against master, but to that branch. And then as each individual change is approved, they're committed to the primary pull request, and then you can begin to understand how those model changes might interact with each other. Frequently, they won't interact with each other in any significant way, but you need to confirm that, right? And so there needs to be an additional approval process as those commits are stacked against each other. But again, each of them are approved individually first, then you approve the stacking, and then once you finish that, you do your final accounting and merge to master, okay? So, I don't know, I'd be curious to hear your thoughts, whether or not either of these workflows or something similar to that seems like a reasonable way to manage the model development process. By the way, I don't know if anybody went to the real world track yesterday, but Max Humber gave a really interesting talk and presented a package called Mummify, which was used Git to help him track during the model development process, during that iterative process that wouldn't necessarily show up here, of making modifications to models and studying their impacts and then rolling back to when things don't quite work right and so forth. It was a really really interesting presentation. I'd encourage you to check that out and check out his Mummify package, by the way. But again, not quite the same here. Here we're talking about a governed process where the iteration's already been done, and we are proposing a change for official approval into the production model. And so some general tips and tricks. I think one common objection to requiring model developers to use Git would be that they're not software developers and that Git is intimidating. That is definitely true, that last thing. And please do not be afraid to use a GUI like SourceTree. I use a GUI, and look, I'm a Git badass. I force push. I rebase to master. Okay? Oh, no, I don't rebase to master. I rebase against master, excuse me, right? And I don't force push to master. I force push to my PR because I want a clean PR. But I still depend heavily on a GUI. I don't do this on the command line, and I don't think anybody should be expected to. So don't try to be a hero. Use a good GUI. Frequently, models do contain data like coefficients and other sort of hyperparameters and settings like that. Make sure to use GitHub-friendly data formats like CSV over Excel. Don't get me started on that. YAML over JSON, actually. And the reason for that is that it's easier to see changes in those files. GitHub has a really nice, for example, CSV formatting in pull requests. So it helps you see what the differences are much more easily than with some of these binary formats or other human unreadable formats. Don't be afraid to include plots and screenshots in your comment threads. Here's a tip and trick. If you're updating the model framework or the model data, you'll need to finalize those changes before you merge in the model instance PR. And you can safely do that because your older models are not going to be using the newer versions of the framework and instance, framework and data, if you versioned them properly. Okay. Now this last point is related to Anaconda Enterprise in particular. During the model approval process, you're going to need a way to exercise that model. So what I recommend is building a separate project specifically for the model approval process. It's an acceptance project that points to the development channel. So now whenever I refresh my model, whether it's by refreshing the whole Anaconda Enterprise project itself, or whether by manually going in and doing a conda update, I'm going to get the latest development builds of that model. And I can do whatever testing I want on that. Maybe I create a second environment in that project that points to the main channel and compares it to production. So I can do version comparisons there. So having a separate model acceptance project is a really kind of simple thing you can do to help streamline the use of Anaconda Enterprise in the model approval process. And you know what? That's all I've got for you. So hopefully I've covered at least some of my ideas and my thoughts about how to do model management using the tools that I already have in my disposal. My Home Depot, my Anaconda, right? So first thing, come tell me why I'm wrong. I mean that. We talk to customers all the time about model management. And every time we do, they say, well, what about this and what about that? We have so many different answers when we ask people, what is model management mean to you? So tell me where I'm wrong. Where does this fall short for your particular application? Come talk to me. Come talk to any of my consulting colleagues, or for that matter, anyone else at Anaconda. We would love to talk to you and understand more about what you need for model management so we can help you build those solutions. I'd love for you to get to know Anaconda Enterprise. We are offering a 30-day test drive. It's a really easy thing hosted on the Google Cloud platform. You get your own instance for 30 days to play with Anaconda Enterprise and get a feel for what it offers you with the Anaconda development platform in the cloud. If you want to, you can go to myanaconda.org channel, which is MCG, the Anaconda Cloud, and actually it's MCG model, as I indicated on there. Sorry about that. And you can play with model packages. Now they're empty. They don't have anything in them. But they show you how you can use, you can still see how the conda process works on installing different packages and models. And you're welcome to play with them. I'm going to leave them up there. And with that, I'm happy to